Good morning, distinguished guests, dear colleagues and friends. It's a true honor to welcome you all at this 7th Waseda Brussels conference, and allow me first to express my deepest gratitude to our distinguished speakers and guests, Vice President Masaito Gemma, Vice President for Waseda University, our Vice Rector Anne Weyenberg of ULB, Professor Frank de Koning, co-director from BRIAS, and of course His Excellency Ambassador Kazutoshi Akiyawa of Mission of Japan to the European Union, together with Ambassador Jean-Éric Paquet for the EU to the Japan, who is not here, of course, today, but he will be here virtually in a few minutes. I also warmly thank all participants, researchers, students, and colleagues for joining us. Your engagement is what makes this conference really, truly alive and meaningful. We are certain that today's program will be both exciting and highly instructive, as we will look forward for next generation quantum technologies. And while quantum physics sometimes seems counterintuitive, after all, particles can be in two places at once, so to say, I assure you that our speakers will remain firmly in one place today, right here, sharing their insight with us. So let's begin this day with enthusiasm, curiosity, and a spirit of collaboration. Welcome.
I have a few remarks to make. Good morning, Your Excellency Ambassador Aikawa from the Japanese mission to the European Union. His Excellency Ambassador Jean-Éric Paquet from the delegation of the European Union to Japan. Vice Rector Anne Weyenberg of the University de Brazil. Co-director Dr. Frank de Koning, Brazil Institute for Advanced Studies. And ladies and gentlemen, welcome to Waseda Brussels Office Conference. I'm Gemma, Vice President for International Affairs at Waseda University. It is my pleasure to welcome you all to today's conference. As one of the organizers and then representing Waseda University, I'd like to make a brief welcome speech of appreciation and introduction. To begin, on behalf of Waseda University, I'd like to extend my sincere gratitude to our co-host, the ULB, for the tireless efforts for organizing this event, as well as the continuous support for the Waseda Brussels office. Thank you. And then to the delegation of the European Union to Japan and the League Europe office for their help and support. And then to everyone here today for your active participation, especially those who have taken their valuable time to prepare for their presentations from Europe and Japan. It has been over 9 years since Waseda University first opened the Waseda Brussels office at the ULB campus. In April 2016, Waseda University has been engaged in collaborative activities with the European universities since the early 1960s to the present. And our scholars have continued to actively pursue exchange in various academic areas. As the process of globalization and movement towards a borderless society have continued to advance in Europe and Asia, academic exchange today has diversified beyond the practice of simple bilateral partnerships to the level of active engagement in multilateral collaborations. In light of this, Waseda University has been seeking to establish research networks across Europe through the Waseda Brussels office acting as a hub and platform. In addition, to deepen communication with various directorates in the European Commission, important scientific contributions in strategically important areas of our researchers can make with European research partners. This time, the research team on the quantum computing and technology from leading research institutions in Japan and Europe will discuss their academic activities with the theme of next generation quantum technology through the future of nanophotonics and atomic physics. I hope this becomes a momentous opportunity to deepen collaborative activities among leading scholars on both sides. Well, the first Waseda Brussels conference was held 2016. The second one in 18, third one December 19, and then fourth one in September 22, and then fifth one in December 23, and then sixth November last year. With this year becoming our seventh, the goal of this conference is to disseminate academic and research discoveries from Europe and Japan, in turn to contribute to the world by making meaningful use of these findings. 2 years ago, we discussed under the title of the new technologies and regulations in Japan and Europe, which examined the three crucial challenges related with the EU-Japan science and technology relations. We discussed the one, interplay between artificial intelligence and intellectual property right. And then second, the role of transparency and then legal safeguards in ensuring the trust in governmental data collection practices. And the third one is cybersecurity implications of the emerging technologies. The European Commission recently introduced a new policy on the use of AI. Our research team, headed by Professor Ueno, studied global collaborations connecting the Columbia Law School and the law school at the University of Hong Kong to discuss global rules on AI use. Third international conference will be held at Waseda University on December 13th, next month, in 2025. I believe that discussions with European scholars in September 2022 have been critical for establishing the research and educational team of experts at Waseda and in Japan. The Moonshot research team on sustainable food supply in Japan that organized the Waseda Brussels conference 2 years ago has been also collaborating with the European scholars after the conference, and then followed up the event last year at Waseda University by organizing an international conference. Ambassador Jean-Éric Paquet also gave encouraging remarks in the conference. As for today's conference, we aim at creating a platform connecting the European Union and then Japan in the research area of quantum technologies. The scholars will discuss their findings and then ways to collaborate with each other. Research collaborations would result in significant social impacts in both parties. In closing, I hope everyone here today finds discussions insightful, and then that the conference serves to further develop the close relationship between the European Union and Japan. Thank you very much again, and then enjoy the conference. The floor is yours. And then we really appreciate that many young scholars are here at present to discuss the various meaningful issues. Thank you.
Your Excellency Ambassador Aikawa, Vice President Gemma, Professor de Koning, dear colleagues, ladies and gentlemen. It is a great honor and a great pleasure to open with you this 7th edition of the Waseda University Brussels Office Conference. Dedicated this year to a highly topical theme, next generation quantum technologies through the fusion of nanophotonics and atomic physics. Since its creation, this series of conferences has illustrated the determination of Waseda and its European partners to build a lasting scientific and academic dialogue involving researchers, policymakers, and the civil society. Together, as was reminded to us by Vice President Gemma, together we have explored many crucial themes for both the European Union and Japan. Today, we take a new step as we address an issue at the very heart of the scientific and technological revolution of the 21st century, quantum science and technology. Quantum technologies are no longer an abstract promise. They are already transforming the way we calculate, measure, secure our communications, model the climate, and develop sustainable energy solutions. They are also at the heart of the AI revolution. The awarding of this year's Nobel Prize in Physics bears witness to the fact that quantum research is one of the most powerful drivers of global innovation. Europe and Japan have made this field a strategic joint priority, as illustrated by the letter of intent signed in May between the European Commission and the Cabinet Office of Japan. This is, of course, a landmark commitment endorsed by the July EU-Japan Summit in Tokyo, which paves the way for a true quantum partnership between both sides. A partnership which should be facilitated by the future association of Japan to Horizon Europe and the programs that will follow it in the future. For the Université Libre de Bruxelles, the prospects are particularly promising. ULB, through the Brias Institute, shared with our sister university VUB, and with its teams in physics and engineering sciences, is a natural partner for Waseda in the quantum field. The synergies are evident. Nanophotonics, quantum optics, quantum networks, but also the theoretical and interdisciplinary dimensions that link physics to computer science, cybersecurity, and biomedical applications. Together, Waseda and ULB will not only strengthen fundamental research, but also contribute to innovative applications that will serve society in Europe, Japan, and beyond. What brings us together today is a shared conviction. Quantum technologies are not only a fascinating scientific field, but they are also a true driver of innovation and a key to the future. They will open the way to computers capable of solving problems unsolvable until now, to sensors of unparalleled precision, to communication networks that are unbreakable. They will provide the indispensable tools to meet the great societal and economic challenges of our time: energy transition, sustainability, digital security, health, and resilience in the face of global crisis. Allow me to conclude by stressing that this conference is not only a place for academic exchange. It is a platform also to build the future, to build joint projects, to build bridges between European and Japanese researchers, to build a future where science and international cooperation naturally come together for the common good. On behalf of ULB and its rector, Professor Ranemi-Scholz, I would like to thank very sincerely Vice President Gemma, Waseda University, the Waseda Brussels office, and especially, of course, Jean-Louis Mourgat, its director, Patrick Vité-Philippe, there, thank you so much, and Guylaine as well. A big thank you also, of course, to all partners and speakers present today, and especially to you, Professor Takao Aoki from Waseda University, because you gave really the substance to the program of today's event. Thank you very much for this. Big thank you also to BRIAS for hosting us today, and thank you, of course, to Frank de Koning, one of its directors, and to Anya Garrone. And I would like also, of course, to thank participants who have braved the Belgian weather, but also the strikes to be here together today, and those who wisely follow us online in Europe and in Japan. I hope that our discussions will inspire new ideas, new collaboration, and that, well, they will contribute to making Europe and Japan, with their universities, with their industries as well, the leading actors who will jointly make the quantum revolution a reality. Thank you very much for your attention, and have a great day.
Excellency, Mr. Vice President, Mrs. Vice Rector, ladies and gentlemen, let me see whether the connection works. Allow me to say a few words about BRIAS. And it works. The institute, the idea for the institute came from the two former rectors, one of the ULB, one of the VUB, the French and the Dutch-speaking universities, Caroline Powers and Yvon Angler. And they said, can you please create the first Institute for Advanced Studies in Belgium? From the French University, my colleague is Serge Jaumin, and from VUB, I am the current director. We had to find inspiration, of course, to do those, but you all heard about the Solvay conferences in 1911, which showed that when you want to optimize new ideas to be created, a very good technique is to bring together leading high-level scientists to let them discuss for a sufficiently long time, and also let them come from different disciplines. And this is an environment where creativity then can really flourish. The second source of inspiration was, of course, the Princeton Institute for Advanced Studies, with famous people such as Einstein, Oppenheimer, Kurt Gödel, etc., where again you offer the possibility for high-level scientists to work together, to stay there for sufficiently long time so that they forget about the daily hassles, and then creativity can really flourish. And this is what we try to do within BRIAS. The aim is brainstorming, getting new ideas, and networking between people that probably would never meet each other at congresses because they come from different disciplines. But they are all interested in the same broad themes, and I will tell you more about this. So our scientific motivation is to give time for research, for writing articles, etc., but especially to discuss together, to disagree, to agree, to have coffee together, and certainly we hope some ideas will come. We are not a simple Institute for Advanced Studies. Those who know VUB, the Université Libre de Bruxelles, and Vrije Universiteit Brussels, I'll say it like this, know that we are not afraid of controversial subjects. Second, we have a special attention for researchers in danger. And the number of researchers in danger today increases, unfortunately. And we also emphasize collaboration with scientists, artists, etc., from the global south, which may not have the financial possibilities to take 1 year off, etc. We welcome them especially. Until now, we have hosted 76 senior fellows, 24 junior fellows, 3 resident artists, and more than 250 guest speakers. They came from about 100 universities or research institutes or policy centers, and they stayed average between 1 and 5 months here in the apartments in this building. We also have resident artists, because the way an artist looks at the same problem is really different. They very often have colliding views with those of scientists, but it provides both with inspiration. And on the left, for example, Christopher Donk, he created a robot woodpecker. David Brinet works on paper folding, and you know, some of the solar panels can be folded and unfolded. Muscles can be constructed in those ways, etc. Guillaume worked on the energy required for AI and robotics and the web. So those are artists' examples. We had 3 teams until now. One was on the past, present, and future of food, climate, and sustainability. This was our pilot project with people from archaeobotany, plant physiology, politics, genetics, history, etc. The second theme was robots, AI, and automation, with conferences on agriculture, human-robot collaboration, sustainable robotic technologies, the use of robots for peace, and unfortunately also for war, etc., to understand the problem, again with participants from extremely different disciplines. And the current theme is on democratic governance, challenges and innovations, polarization, populism, short-termism, misinformation, influence of AI, etc. A very well, I would say, chosen subject for the current times. This was a very short overview. Brias really wishes you a very inspiring conference. And whenever you know the date of the next conference, tell us, because we have to reserve the room well in advance.
Thank you.
Have a good conference.
Well, good morning. It's working? Okay, good. My name is Kazutoshi Aikawa. I'm serving as an ambassador to European Union, and I thank you for giving me an opportunity to get out of this Brussels bubbles, EU bubbles, and to be able to interact with people here. Professor Gemma, Professor Anjenberg, and Professor Komick, and I, to all the participants, thank you very much for inviting me to this conference. It is a great pleasure for me to be back at ULB and to join you again at this Waseda 7th Waseda Brussels conference this year. And this year also carries a special meaning for me and my mission, Japanese mission to European Union, because this is 50th anniversary of our mission here in Brussels. So it's something to to celebrate for us, and I am very happy that this conference is taking place in conjunction with that. I am also delighted that the ULB has been deepening its engagement with Japan. It established a Japanese language course in 2016, and it also launched a new master's program this autumn. So as we approach, well, we have another celebration coming up next year, 160th anniversary of Japan-Belgium diplomatic relationship. You could say the Japan-Belgium friendship. So that I'm hopeful that your initiatives will further expand Japanese studies and strengthen mutual understanding here in Brussels. This year, as Professor Ann Weyemberg said, that this year's Nobel Prize is awarded to those scientists in physics in quantum technologies. But I also, need to remind you that the other Nobel Prizes, the Nobel Prize in Physiology and Medicine, and Nobel Prizes in Chemistry, also awarded to Japanese scientists, and that, I think, demonstrates the strength and global contribution to the Japanese scientific community. And these achievements are reminders that the scientific progress thrives when ideas and talents move freely across borders. So on the governmental side, Japan and the European Union signed a memorandum of understanding on cooperation in quantum technologies, again that referred to Professor Weyemberg. And Japan also has similar MOUs with Denmark, the United Kingdom, and Germany and Switzerland in this. In parallel, the negotiations are accelerating on the Japanese association to Horizon Europe. Horizon Europe, I believe, will offer a tremendous platform for deeper scientific and technological engagement between Japan and Europe. So against this dynamic backdrop, I am delighted that today's conference focuses on quantum technologies, the technologies that may shape the future of the world we live in. The presence of participants from Belgium, France, Germany, Italy, Spain, and the United Kingdom, and Japan, of course, reflects the global nature of this field and the shared interest in responsible advancement. Waseda University has long been a leader in international collaboration. The scientists and researchers, their scientists and researchers are contributing to global innovation. So I understand that Professor Aoki, his work has recently attracted significant attention from both academic and industrial community, and very much look forward to his presentation and our exchanges that will unfold today. Japan and European countries are strong partners in quantum technologies, advanced materials, and digital innovations. These efforts demonstrate not only our mutual strengths, but our shared values, trust, transparency, and a commitment to open and secure research environment. And as emerging technologies increasingly influence our global landscape, cooperation between universities, research institutions, and other stakeholders becoming even more essential. So I hope today's discussion will generate valuable insights and inspire concrete collaboration that will contribute to more innovation and more science-secure future for all of us. So, let me thank you again for all those participants and all those people who are involved in the preparation of this conference in the midst of this national strikes. So thank you for that. So just, the mission is always, stands ready to work with you as you, move forward. So thank you very much.
Okay, and now we leave the floor to Ambassador Paquet for his presentation.
Good morning, ladies and gentlemen. Vice Rector Weinberg, Vice President Gemma, Ambassador Aikawa, Patrick Vité-Philippe, dear colleagues, I would like to thank you very much for the invitation to make a video address to the 7th Waseda Brussels conference. I regret I'm not here in person, but I'm really delighted to contribute to the event with this video. Many developments are taking place in the quantum field, particularly now that researchers are building new technologies and systems that make use of quantum mechanics, leading to rapid advances in technological innovation in quantum computing, sensors, simulations, cryptography, and telecommunication. Alongside the research and technological developments, there are also many policy developments which now nurture and foster innovation in quantum technologies, both in Europe and, of course, in Japan. For Europe, we recognize that we have a long and distinguished track record and history in quantum research, with iconic forerunners such as Max Planck, Albert Einstein, Niels Bohr, and Erwin Schrödinger, as well as current-day pioneers and Nobel Prize laureates. And we continue to invest heavily in this field. Europe wants to be a leader in quantum products and services in a global and open market where we hope that Japan can also be a leader alongside Europe. Over the last 5 years, the European Commission has provided total funding of nearly 2 billion euros for quantum research. Quantum sensing, computing and simulation, quantum communications, and basic science. This is complemented by a staggering 9 billion euros of funding from our member states. But we now find ourselves in a situation where we need to do more to boost research and innovation, more to scale up industrial capacity, including developing pilot lines and a design facility, and to reinforce supply chain resilience and governance. To do this, we are proposing a new Quantum Act scheduled for adoption in 2026. There is right now a call for evidence for this act, which is open until 26 November, tomorrow, and I encourage you all to contribute to this exercise if you haven't done so yet. Let me also say something about our European Union-Japan cooperation in this field. In the EU-Japan Digital Partnership, first agreed back in 2022 at the EU-Japan Summit, we continue to advance our cooperation agenda across a range of different digital topics: semiconductors, telecoms, cybersecurity, data and data governance, AI, high-performance computing, and digital identities. Of course, we are also promoting cooperation on quantum technologies. On the 23rd of May this year in Tokyo, a letter of intent with Japan for quantum science and technology cooperation was signed by the Science and Technology Minister Minoru Kyuchi, and Executive Vice President Hanna Virkkunen. with the aim to strengthen our cooperation into the future as quantum technologies slowly mature into commercial applications. This letter of intent should position us to work together more closely, as it will enable us to implement joint projects via the Cross-Ministerial Strategic Innovation Program, SIP, and Horizon Europe. One comment here on Horizon Europe. We are right now completing with Japan the negotiations. I'm sure many of you are aware of that development, so without wanting to anticipate what remains to be done, I am today really optimistic that Horizon Europe will shortly also be available to support research, including in that area. We also share information about domestic funding priorities and coordinate the development and support of research and innovation activities, research facilities, as well as science and engineering education in the field of quantum science and technology, and explore the possibility of reciprocal forms of collaboration to facilitate the participation of QST communities in each other's respective programs and initiatives. We have already launched a research and development project that will bring together 16 partners across Europe and Japan to advance hardware, software, and hybrid high-performance computing, quantum computing environments for applications in biomedical research, material science, climate modeling, and natural disaster simulation. This project called QNECO, will emphasize integration with quantum-enhanced machine learning and AI technologies. The project is coordinated by ICE in Japan and the Finnish IT Center for Science. The European Union provides 4 million of funding, and the equivalent funding coming from the Japanese side. So a meaningful, well-funded project. In closing, let me say again how much I welcome today's 7th Waseda Brussels conference. Very grateful also to the Moonshot project for supporting today's event. It will, I hope, foster more collaboration and exchange between Europe and Japan in this important area of research and market of tomorrow. As you can see, the framework is there for you scientists to pick it up and run with it. Thank you very much. Have a good conference.
Okay, after this very inspiring words, we can start the scientific part of the conference. And so I'll leave the floor to Professor Aoki, which I'm very honored to present to you. Thank you.
Thank you. Yes, please. Okay, I'm Takao Aoki from Waseda University, and on behalf of the organizers, I would like to begin by thanking all of you for joining this conference today. So in my talk, I will give you an overview of the quantum technology we are developing at Waseda University, and I hope that this introduction will serve as a foundation for our discussions throughout today, and to explore new opportunities for scientific exchanges and for building new collaboration arising from this conference. Yes. So let me start from the introduction. So quantum technology is expected to bring transformative changes to our society, and it has become one of the highest priority areas for public investment, both in Europe and in Japan. For example, in 2022, the Cabinet Office of Japan formulated
vision of quantum future society, outlining a long-term national strategy for advancing quantum technology as a whole country. And it envisions a future in which quantum technology creates significant values across all areas of society, as illustrated in this picture. And there are three major pillars of quantum technology that will make this vision possible. Quantum computing, quantum communication, and then quantum metrology or sensing. And for example, the quantum computing will enable ultra-fast computation for problems that are intractable for conventional computers, even with the highest performance supercomputers. It will allow us to tackle tasks that are far beyond the reach of today's most powerful supercomputers. And currently, quantum computing hardware is being developed across a variety of physical platforms, including the superconducting circuits, ion traps, photons, neutral atoms, and semiconductor quantum dots, and others. And over the past decade, the progress in quantum computing hardware has been truly remarkable. The number of qubits, that's the unit of the quantum information, implemented in the hardware has increased following what is often called the quantum version of Moore's law, starting from like handful of qubits 10 years ago, have now reached the level of almost 1,000 today. However, theories suggest that actually more than 1 million qubits or even more qubits will be required to build a truly useful fault-tolerant quantum computers in this regime. It is widely believed that simply extending the current approaches will not allow us to keep scaling this Moore's law. In other words, fundamentally new strategy will be needed to bridge this enormous gap. And a promising approach to realizing such a large-scale quantum computing hardware is the scheme of distributed quantum computing. So in this scheme, many small to medium-scale quantum computers or quantum processing units are built and connected to form a quantum network like this, which then functions collectively as a large-scale quantum computer. And this is precisely where the fusion of nanophotonics and atomic physics comes in. By combining nanoscale photonic structures which strongly confine and guide light with the exceptional coherence and the controllability of laser-cooled atoms, we can create highly efficient interfaces between the atoms and photons, or stationary qubits and flying qubits. This fusion offers a powerful pathway toward overcoming the key challenges in distributed quantum computing. And specifically at Waseda University, our group aims to develop a quantum platform based on nanofiber cavity quantum electrodynamic systems, nanofiber cavity QED systems. This all-fiber architecture can host many individually addressable atoms, the stationary qubits, while also enabling high-efficiency interconnection through the standard optical fibers, which transmits the flying qubit, the photons. So with this platform, we envision powerful capabilities for realizing large-scale distributed quantum computing and quantum network. So please allow me to go into a little bit in the detail of the science part. So our device or cavity is fabricated from a single piece of optical fiber with the central section tapered down to a diameter smaller than the wavelength of light typically around 400 to 500 nanometers, as shown in this scanning electron microscope picture. And this is why we refer to it as a nanofiber. And this nanofiber region is seamlessly connected to a standard single-mode optical fiber through smooth tapered transitions at both ends. And in these thicker fiber regions, fiber bar gratings of FBGs are inscribed to serve as highly reflective mirrors. So this forms an inline Fabry-Perot cavity fully integrated in fiber, an approach first demonstrated by Professor Walsh-Boytel, who will give us an invited talk later today, his group. Yes. And a key strength of our research lies in our ability to fabricate extremely low-loss nanofiber cavities. So the low loss, intrinsic loss of the cavity leads to strong light-matter interaction and enables quantum functionalities with higher efficiency and higher fidelity. Losses in the nanofiber cavities have two origins. The one is the loss at the taper region, and the other is loss at the FBGs. And we have lowered both of these losses down to less than 0.03%. And then the estimated round-trip loss of the cavity, whole cavity, is approximately 0.1% or even less, corresponding to the cavity finesse of 6,000 or higher. So with such parameters, we expect to achieve a cooperativity, the single atom cooperativity exceeding 100, which will enable the realization of fault-tolerant quantum computing in a distributed architecture. And we construct a cavity QED system by placing an atom within the evanescent field of this nanofiber region. About 10 years ago, we demonstrated a strong coupling of single atom to the nanofiber cavity. At that time, the cavity finesse was very low. Actually, the finesse was as low as 30. It's like 20 times lower than the current status. But still, even with such a low finesse, we could observe a clear Rabi splitting, which is a signature of the strong coupling between the single atom and the photon inside the, confined in the cavity. And then we demonstrated a coherent, reversible coupling of two cavity QED systems. So we observed all 5 normal modes of the coupled cavities QED system, which is the proof that the photon can go back and forth between two cavity QED systems many times before being lost in the connection channel. This is an important step toward realization of distributed quantum computing and quantum network. And now we are currently developing a new scheme for trapping many individually addressable atoms on the nanofiber to be able to control each atom individually while keeping them strongly coupled to the photons confined in the cavity. Specifically, we place a site-resolvable lens next to the nanofiber. And in combination with the spatial light modulator, we generate a one-dimensional array of optical tweezer traps for trapping single atom in each of these spots. So far, we have successfully trapped a single atom in the optical tweezer, and we observed its resonance fluorescence image through this spherical lens, which also we used for forming the optical tweezer trap. And furthermore, we also observed the cavity-enhanced resonance fluorescence through the cavity from the same single atom trapped on the nanofiber. And then using a spatial light modulator, we are generating approximately 10 optical tweezer spots along the nanofiber. And furthermore, very recently, we are trying to increase the number of atoms coupled to the nanofiber. So with this new setup, we estimate that we should be able to have 1,000 atoms on the same fiber in an individually addressable way. We are starting from a little bit smaller number. We have succeeded in generating an array of about 200 optical tweezer spots on the nanofiber. And now we are trying to load atoms in these spots by creating an elongated magneto-optical trap around the nanofiber. And now we are starting to see some signals from loaded atoms in these one-dimensional array of optical tweezer spots. So please stay tuned. Yeah, so to summarize, we have been developing a nanofiber-based cavity QED platform that integrates strong atom-photon coupling, scalability, and fiber connectivity, which are all key features for distributed quantum computing and quantum network. And I'm looking forward to the invited talks, poster presentations, and the discussions we'll have for the rest of the day to explore new opportunities for scientific exchange and for building new collaborative projects. Thank you very much for your attention.